Hey friends, so in this video we are going to study about the beam balance, the spring balance, how both of these works, and most importantly which of the two can be used on any planet without any modification. And we are first of all going to use this beam balance to find out the mass of this blob. When I put this blob in this particular pod, the gravitational force is acting on this, which is equal to mg, right? And this force which acts on this part is producing one torque here, due to which this turns like this. Now, if we go on adding some standard masses on another pot or another side of the balance, let's say I will first of all add the standard weight of 50 grams. Okay, there is additional torque which is opposite torque which is produced on this side. So see, if this is 50 gram mass, the gravitational force is acting on this too, which is equal to 50 gram into g, right? So that torque is trying to rotate it on this side. If both of these torques are equal, then the beam will be balanced. Now I will try to add this 10 gram mass, and okay, beam is balanced now. Now what's happening over here? In this particular case, both of these torques are balanced because as these two distances are equal, the torques are balanced because both the forces are equal. The force acting on this is equal to mass of blob into g, gravitational acceleration, and in this case it is mass of the standard mass here into g. These two forces are equal. As the two forces are equal, I can write m into mass of blob into g is equal to m as standard mass into g. On both sides I can cancel g and we get the equal masses on this. So whatever is the standard mass I use in this particular pot, the same mass will be that has to be kept here, and then only this balance we get the balance and we can measure the mass of any object. Now see, if we go to any other planet, then what will change? The gravitational acceleration will change. The forces acting both of these pods will change, but it will be equal again, right? So on the moon, what will happen? The force acting on this is m blob into g of moon, and in this case it will be m as standard mass into g of moon. Again, g of moon can get cancelled and equal masses. So this balance can be used on any planet without any modification, and you can still measure. Okay. Like if let's say you want to measure 1 kg of sugar on moon, right? Then again you will put the standard mass of 1 kg on this one pot and 1 kg sugar. You can measure the 1 kg sugar spring balance. I will put this here, and now you can see the reading. It shows us the mass of this blob should to be 60 grams, right? But remember, if I take the same arrangement on the moon, the reading would have been 10 grams instead of 60 grams. And why is it so? So for that, let's understand what is the basic principle behind spring balance. Friends, here inside there is a spring, and springs obeys the Hooke's law. What's the Hooke's law? The Hooke's law states that if we change the length of the spring, if we stretch it or if we push it inside, if we change the length of the spring by x, then there will be restoring force which is proportional to x, right? And the proportionality constant k, right? Proportionality constant k is called spring constant. So see, F is equal to minus kx. Why minus kx? If I am stretching the spring, the restoring force is in the opposite direction, which is trying to get it back. In this particular situation, what's happening is the gravitational force or gravitational pull acting on the blob, which is equal to mg, mass of this blob, into gravitational acceleration, is balanced because see, here this blob is at rest. That means surely equal and opposite force is acting. What is that opposing force which is pulling it upwards? That is the restoring force of the spring, which can be given by Hooke's law. That is equal to this stretch, right, into k. So kx is equal to this. what's happening over here is this mg is balanced by kx, right? If we know the k for the spring, by just knowing the stretch in the spring, we can find out how much mass is present here, because we also know the g. But what will happen in case of on the moon? Stretch of the spring is actually dependent on the force acting on the on it, not the mass only, right? I can write x is equal to mg upon k, right? So on the other planet g will change, and that's why x will change. For example, this blob produces m into g force here, and that's why we are getting this length to be equal to this much. But on moon, this pool will be equal to mg by 6, because gravitational acceleration on moon is 1 by 6th of the gravitational acceleration on the earth, and that's why we will get only 1 by 6th of the stretch, right? That means if I want to use this particular spring balance on the moon, I will have to change this scale, and instead of 10, I will write 10 by 6, instead of 20, I will write 20 by 6, instead of 30, I will write 30 by 6, instead of 60, I will write 60 by 6, that is equal to 10 grams, and then I can use this particular balance. Remember, this balance actually measures the weight, that is in Newton. Out of these two balances, this beam balance can be used on any planet without any modification. These two can be used, but there are few modifications to be done based upon the gravitational acceleration of that planet. Thank you.